Last time we've had a little intro in JavaScript. Unfortunately, we've had to hurry to a certain extent, so we're going to go through some of the things we've missed, and then we're going to mainly talk about arrays and functions. Um, we are going to talk a bit about objects, but a bit at a more conceptual level, and this is going to leave objects and asynchronous programming for next time. So first things first, like I said, we can run JavaScript in multiple contexts. And last time we've run JavaScript as we've run our JavaScript examples as console applications. Now, for the sake of variation and to actually highlight the thing that JavaScript runs under multiple contexts, we're going to do the examples today in the browser. So if we want to do them in the browser, what we're going to write is some HTML files. They're going to be minimal, so it doesn't matter that we've not talked about HTML in depth as of yet. So the smallest HTML file that runs JavaScript, which I may have, it's this one. And whatever I write in this script tag is going to be my runnable code. So let's start with the classical hello world, basically. So we just see that it works. Now, if I go to my file and I open it, I'm gonna get it in Chrome. There's nothing to be seen here. However, if I press F12, I can actually see hello in the console. Now, notice a couple of things. Like I said, it's a different context, but we also have access to some global objects here. Incidentally, console is a global object which is valid both in the command line, in the node version, and in the browser version. However, you've seen at the tutorials something with command line arguments which were taken from a process global object. Now, that process global object can't be visible here because it would be a security risk. However, I have some other things. I lose some toys, but I gain some toys. And I can write something like document write hello again. And if I refresh the page, I'm gonna see hello again. Now, something interesting has happened here, and it's of great importance to the type of applications we're writing, which is our initial HTML was pretty barren, right? There wasn't much in it. And if we look at, say, in a React application, it's going to be similar in the sense that I'm going to have a really simple HTML, which isn't going to suggest what's happening there. But that structure, the structure of the HTML, is going to be dynamically modified at runtime. This is going to mean that our JavaScript is actually going to populate our document. And when we've written something with document write, which is a naive approach, we can see that it actually appeared in the DOM, right? So the browser took our JavaScript code, executed it, and then, based on what it said, it modified the DOM and re-rendered the page. And this is the general principle of a single page app. We're not going to delve too deeply into this, though. We're just interested in exploring JavaScript for now. So let's make a new file. Let's abandon this one, and let's talk about some more JavaScript related things. Now, we've seen that JavaScript has a limited number of types which are included in the language, fundamental types, and I have some basic types and some complex types. Now, as for basic types, let's note a couple of things which are, let's say, JavaScript specific, or they're interesting in relation to the language. So I had numbers, and numbers were always floating point. I didn't have integers. Then I had booleans, and what's interesting here is that everything can be evaluated to a boolean, right? So a number has a boolean value. I can evaluate it to true or false, or a string, or so forth. And then I have strings. Now let's note a couple of things about strings, right? First, so I could declare strings like this. So S1 is I am a string, but also S2, the same thing between double quotes. Now these two are identical, right? So there's no difference between them. So why do I have two kinds of syntax? Well, I have two kinds of syntax because I might want to include either a single quote or a double quote in a string. And if I have to do that, I merely have to switch the string delimiter. and that's it, right? So this is going to be just a regular character. Let's just see them to the console. Okay, right, so this worked. And I didn't have to use any kind of escape syntax or anything like that. However, I will have to use an escape syntax if I need both of them, right? Because, for example, if we do this, and when I have s3, I am a apostrophe and double quote string. There's no way to write this without interrupting the string somewhere. So I have an escape syntax which is based on backslashes, just like in C. And I can also write stuff like \d for tabs, and just like in C. So I can escape my character. If I want to escape backslash itself, it's going to be \\, exactly like you've encountered in countless languages until now. So these are my basic strings, let's say, but I have another way of declaring a string, which again is of importance when we talk about the browser, about writing things in the browser. So let's first let's write this one to the console. Right, that worked. So apart from enclosing strings between single quotes or double quotes, I can enclose them between back quotes. So this thing. Now back quoted strings have two applications. One sec. Let me just pause this. Sorry, I had a little interruption. Um, so back quoted strings have a couple of applications. So they behave differently from the other kinds of strings in two ways. One of them is if I go to one of these strings and put a new line in it, it's going to break it, right? So the interpreter will not know how to interpret this. However, in a back-quoted string, I can actually write something multi-line, right? And if I write this to the console, I can see that this is preserved, right? So it's I am a multi-line string. Right, the second thing I can do with them. Now, this is maybe it's not apparent what it's useful for. Well, what it's useful for is, for example, let's say we have to write some HTML code, right? And we want to hold it in a string to do something with it, to modify it, to construct it, to whatever. And then we want to insert it somewhere on the page. Now, the problem is it's going to be really hard to read, right? So if I put it in a regular string, I'd have to write everything on one line. However, if I put it in a multi-line string, I can maintain the indenting, right? So this is going to get to make my code more maintainable, right? I'm going to be able to more easily understand what's happening. Now, the second thing a multi-line, a backquoted string can do is it can be a template string, right? So I can write something like this. I can say one of these expressions, so dollar and a pair of curly braces, and then some value. And my string is going to be, when I calculate what my string is, I'm going to first replace this with the value of s1. And this is going to allow me to do a bunch of things. For example, if I think about having an array of URLs which contain links to pages, right? I have multiple pages in something, multiple pages of users, and I want to compose these. What I might do is use one of these template strings within a for, and the value there would be the I of the for. Right? So I can easily manipulate strings like this. And let's just check that this happens. Now, we've briefly talked about arrays. Now, something to note is that strings behave very much like arrays in JavaScript. There's an exception to this, but I can write something right. I can write something like this, so I can index it. I can also use a bunch of array methods on strings. We're going to see some of them shortly. I can also iterate for strings. What I can't do is modify them in place, right? Because strings are immutable. So I can't do s1 of 3 equals something. Um, so that would be about strings. Now let's get back to our arrays. Now arrays have a really interesting interface, programming interface, in the sense that there are some traditional methods and there are some new methods, some methods which are higher order. Now, what I mean by higher order, when I mean by higher order function, and by extension by higher order method, is a function which has at least one of its parameters another function. It's a function of a function. And methods are just functions which are aware that they're called on a particular object. Right? So they're just functions which know who this is, right? Who the this object is. Now we're going to talk about them, but first let's go through some of the traditional methods which are really useful and interesting. And then to talk about the higher order methods, we're going to have to look at functions for a bit. So first things first, let's have an array. Something to note is you see we're declaring variables with let. And this is not the only way of declaring variables. Let's chat about this for a bit. So in JavaScript, and then we'll get back to our arrays. So in JavaScript, I can declare these with const, let, or var. And let's see what the difference is. Now, when talking about const, I have something which I imagine it's a constant is a constant. Let's have a naming convention here. Some constant. Now I've named it correctly, let's say due to based on some naming scheme. I gave it a value, but nothing prevents me from going further on the code and doing this. Now this, if I set let, this would be valid. So what I want from const is to tell me when I'm trying to modify something which is supposed to be constant. And it's going to tell me by giving me an error, right? So I don't modify constants. Now, as for the other two, which are let and var, the difference is rather subtle. So var is the way that variables have been declared in JavaScript since the beginning of JavaScript, and let is something more modern. Now let's see why let exists and why we should prefer it. Now let's assume we have some sort of for, and it has a counter which is defined with var. And our for doesn't necessarily do anything, right? So in other languages, when I see this sort of structure, I'd expect I to be valid inside this block, right? So it would be visible inside the block and invisible outside the block. But in JavaScript, if we log I to the console, we're going to see that it's actually going to be 10. And this means that obviously I wasn't visible just inside this block. The reason is that initially, when you declared a variable in JavaScript, it would have been visible inside the function it was declared in. So it would have been something which is called function scoped. Now, function scoped is something which is not necessarily frequently encountered in other languages. It's a bit more unintuitive. So, at some point, we got the alternative, which is declaring this with let. And this is block scoped. So it's visible just inside that block. And to check this, if we try to print j, we're going to see that j is undefined. Now, this is actually, despite this peculiarity, there's another interesting discussion to be had here about what a scope actually is. Now, I said that, first of all, I said that I is function scoped, so it's visible within the first enclosing function. Now, obviously, there's no enclosing function in our code, so what did I become? Well, it became a global variable, right? Which is it's a bit strange and it's a source of bugs. Generally, we're not going to have any motivation to use var instead of let, right? Let gives us the more intuitive code. Although we can imagine some edge cases where we'd want to use var, we're generally not going to encounter them. Right, so like I said, this brings us to an interesting discussion about scopes because, and we're going to come back to this when we talk about functions, but in other languages, scopes are abstractions, right? They're just instructions for the compiler or the interpreter as to the visibility of some variable. But in JavaScript, things are a bit different in the sense that scopes are actually concrete. Now let's think about let's take a little sidetrack and talk about objects, right? If I think about objects and I want to define what an object is, I could go through a goal focus lens and say that objects are a way through which we group uh, attributes and behavior, right? So we put in the same place attributes and behavior. Now we could abstract this a bit more and just say, well, we could represent objects as a list of key value pairs if and only if the behavior can be represented as a value, right? If I have functions as values. If I go even deeper than this, I could say that I could represent an object just as a list of pointers. Now, in JavaScript, functions are values, and we're going to see what this implies, this entails later. But the idea is that objects are lists of key value pairs. And for these reasons, objects in JavaScript look very much like key value pairs. They just look like hash tables. Um, Now, what does this have to do with scopes? Well, in JavaScript, like I said, everything's concrete. So what scopes actually are uh, is similar to objects, right? They have a representation which is similar to objects. So scopes themselves are actually lists of key value pairs. And some of those keys might be numbers, and some of those keys might be functions, right? And even if I can't explicitly get a reference to this pseudo object representing a scope, it exists. Okay, we're going to go back to this, but let's return to our arrays for now, and let's see something a bit simpler, which is so I have an array. Let's declare it with let, and we're gonna have let's have the elements exactly the same as the index. Right, so this is an array. Now, what might I do with the array? There's a bunch of methods which are important and which exist on array in the traditional, let's call it, interface. So they existed in JavaScript since the beginning. Now, I'm going to note again that arrays in JavaScript do a lot of things, right? They can function as stacks, they can function as queues. So an array, for example, has a push method and a pop method, which allow it to function as a stack. It has a unshift and a shift method, right? So adding at the and extracting at the end, adding and extracting at the beginning. So I can combine this to get something which behaves like a stack or like a queue. Now, apart from these, I have some other things. For example, I have a method which is called indexOf. Now, what indexOf is going to give me is the first element, which is equal to whatever I pass as a parameter. So if I wonder what is the index of 3, I'm going to get 3. Now, this is intentional. Like I said, we use just the index, the value, same with the index. What happens if I wonder what's the index of 10? Well, 10 doesn't exist in the array, so what I'm going to get is -1. Now, the reason why I get -1 is that it has to be an index which is going to signal that the element doesn't exist in the array. And since arrays are 0 based, so 0 is a valid index, I'm going to have something which is outside this range of possible indexes, and in this case it's -1. Now, the second method we're interested in is a method which allows us to get a copy of part of an array. Now, in other languages, unfortunately not in JavaScript, I have an operator for this. It's called the slice operator, right? So if I look at, say, Python, on a list, I can do something like this, right? So that's going to be elements with indexes within the slice to a 4. which means this is going to be a sequence of numbers which is going to be closed downwards and opened topwards, right? So it's going to be, in this case, it's going to be indexes 2 and 3, right? It's going to be closed towards 2, but open towards 4. Now, I don't actually have this syntax in JavaScript, unfortunately, but what I do have is a function on an array, which allows me to have all the functionality, even if not the, let's say, the elegance of it. Now, what Slice does is it creates a copy. So, for example, if we were to say a1 is a.slice between 1 and 4, this is actually going to give me all elements with an index between 1 and 4 as a slice. So index is 1, 2, and 3 because it's closed downwards, open topwards. So let's see a1. Right, so it works exactly how we expected. We can also get a slice which is a copy of the original array, and for this we can write something like this. So between 0 and a dot length. And from this expression, I can maybe understand why the slice is open topwards. Right? It's just so I can do stuff like this. Because length is going to be 1 larger than the index of the last element in the array. Let's see a2. Right, so it's a copy of the array. Now this method is non-destructive. It doesn't modify the initial array in any way. We have another method though to modify the array, and this is again this is from since it's from the beginnings of JavaScript, it has the same style of overloading a lot of functionality over a single thing, and it's called splice, like in gene splicing. Right, so splice, what splice does is it cuts part of the array and then replaces it with something else. What it returns is the part it cut. So let's say we have a3 is a dot splice between 1 and 3, right? So this, no, not between 1 and 3. So starting from 1, 3 positions, that's what it means, right? So starting from 1, 3 positions, and then I have whatever I'm supposed to put in its place, not necessarily the same number of elements, right? So so here I can write something like this. Right, so first let's see what a3 is and what a is now. This is a destructive method, so it's modifying a. Right, so I took out 1, 2, 3, and I replaced them with a and b. Now, a couple of things to note. First things first, it used to be an array of numbers, now it's an array of something else. What else? Well, it actually was always an array of objects. And because JavaScript is so passionate at implicitly converting things so that it works, what's happened here is that all these elements are valid, right? Because all of them can be converted to objects. They can be wrapped in objects. Right, the second thing is if I look at Splice, I said I can write here no matter how many elements. Now, this leads me to the fact that Splice is what is called a variadic function, right? It's a function for which I don't know the number of elements beforehand, before calling it. And we're going to see our own variadic functions soonish. Right, so that's Splice. Now, something else which is interesting is that I have a pair of methods, one on array and one on string. Well, there's somewhat of a pair, we'll see shortly, which are going to allow me to transform a string, to split a string into an array, or to join an array into a string. So let's see that. Right, so first of all, we need a string. So let's say we have string s, and let's say it contains a, comma, b, comma, c, d. Now what I can do is call a method on string called split, which receives some sort of separator as a parameter. In this case, it's comma. So I'm going to get an array of strings. Right. Now apparently, right, the inverse to this is join. So what I can do is obtain another string. So I can do something like a.join, and let's use another separator, let's say based on star. But I could easily have used comma, and I would have gotten the initial string. Now they're not exactly mirrored, however, because string.split, we've given it a character, but we can give it something else. And what we can give it is a regular expression. Now, we're not going to go into deeply on the syntax of regular expressions, but my recommendation is that you look over them, because there's something which is really useful and which has existed since programming languages have existed, so it's not changing. Now let's say our string is something a bit different. So it's a, comma, b, but now we have a dot, a period, right? So c, and then a bang, and d. And we want to separate this into its atoms based on any one of these separators. Now we could do some really complex logic, which should be recursive, in which we split based on something, then on something else, etc. Or we could use a regular expression. So we're going to say a1 is s1.split, and here we want a regular expression. Now a regular expression is actually an object, so we can do null regexp of something. But it also has a syntax which we can use in line, which is this syntax. And in this case, it's going to be, like I said, let's not worry too much about the syntax of regular expressions, but it's going to be any one of the group of characters we've talked about. Let's write a1 to the console. Right, so that works. Unfortunately, I can see that split isn't actually the reverse of join, or join isn't actually the reverse of split, because I couldn't recompose it with the same separators. Right? I have to know the position of each one of them. I have to write a little algorithm for this, so it doesn't work like this. Right, now we're down to our higher order methods for arrays. But in order to talk about this, let's talk about what functions are, what methods are, and then we'll get back to arrays. So first, what functions are. So if I were to declare a function in JavaScript, I could do it in multiple ways. There's a subtle difference between these ways, but we're not going to get into it today. So for now, let's consider them equivalent. So the first way is to say a function f of some parameters a, b, and c. Now, if I were to leave it like this, I'm going to notice a couple of things. One of them is, obviously we're in a dynamically typed language, so there's no types anywhere. Second thing, I need a keyword. The reason I need a keyword is to declare the function, just like I do in Python, is because I don't want to have confusion between declaring the function and calling the function. Third thing, this function doesn't return anything. Now, because it doesn't return anything in JavaScript, a block which doesn't return anything is going to return undefined. But let's write something in it, and let's call it. Right, so it gave us 6. But if we think about it a bit, it's a bit more interesting than that, because we've not specified the type. But if we were to just infer what the type of the type returned by this function is, we couldn't actually say, could we? Because here I called it with 3 numbers and it returns a number. But what if I call it with 3 strings? Now plus is an operator which is overloaded, which means it also works for strings as concatenation. And this time my function returns a string. Right, but what's gonna happen if I call it with some strings and some numbers, etc.? Well, let's see. Well, if I were to replace this with numbers, I'd actually get a number. I'd actually get a string, sorry. The reason why I'd get a string is JavaScript is going to try to make this work. So it's going to have the addition or concatenation between a string and a number. I can't actually add strings and numbers, but what I can do is concatenate the string with the string representation of the number object which wraps this primitive. So the result here is going to be 823. Right. Now, what if I give it more parameters? Well, nothing's gonna change. The other parameters are safely ignored. I can give it no matter how many. And since the function inside of the function, we only take into consideration 3 parameters, they're not gonna matter. Well, what if I give it less parameters? Well, interestingly, this is also going to work. Right, so instead of giving me an error, what it's going to give me is it's going to consider that C is undefined. So what I'm going to get is a string. So it's going to be A2 undefined. Right, so can I handle this situation somehow? Well, I do have default parameters, so I can say something like this, and this means, well, C, if the invoker of this function provides a C, it's that value of C. But if they don't, it's just going to be 4. So there's a default value. Right, so this is somewhat how regular functions work. Now let's explore there's one thing we want to discuss this a bit later, which is how do I handle an arbitrary large number of parameters, so variadic functions. But first, let's try to define a different function and define it in multiple ways, so we see what goes on there. So first off, let's have a function called f1 of some x, which returns x times 2. Simple enough, return. Simple enough, we can write this to the console just so we see that it's working. Right, and it should give us 2. Okay, now the other way of defining a function, like I said, for now we're not going to discuss the distinction, uh, is through an arrow function. But before we get to an arrow function, let's see something else. Well, I said that functions are values. Now, if functions are values, I should be able to write some sort of expression which evaluates to a function, right? Just like I can write some sort of expression which evaluates to a number. Well, I actually can. Let's say f2 is function of x, return x times 2. And this is the same thing, um, only this is an expression for an anonymous function, right? It's anonymous because it doesn't have a name. Now, there are some consequences to this. So first things first. So this is an expression which evaluates to a function, and we store the result of this in f2. But since we're in JavaScript, we can do something like this. So what happens now? Now, we should discuss something else here, which we've glossed over. We've kept declaring things, and we've never wondered how they're allocated or deallocated. But obviously they are. Now, JavaScript is a garbage collected language, like most application level languages. So we don't have to worry about that. So the way this is going to work is whenever I allocate some object in memory, it's going to stay there for as long as it has a valid reference to it, because periodically the garbage collector goes through the memory, and if it finds some sort of allocated zone to which there doesn't exist a reference, it's going to just deallocate it. Right. So what happened here is f2 was a function here, but at this line, f2 became a number, which means that the reference to whatever the function representation was lost. But we're talking about references in relation to functions, right? And this works because in JavaScript, functions are also represented as objects, and they have their own little properties, for example. For example, a function has a length property, right, which is going to be the number of parameters. It's so-called arity. Right, so before we give up f2, let's just call it with 2 so we see that it worked. Now the next way of doing this, it should seem familiar if you've worked with collection streaming in Java, which is we can use an arrow function. And this is going to be another kind of expression. For now, we're going to write it similarly to how f2 looked like. So it's going to be like this. Now we have a way of reading this. So it's this is actually read as with x, and what's on the right of the arrow is going to be evaluated. So it's with x block. Now the block, like in the function discussion, returns undefined if it doesn't have a return statement in it. So in this case, we have a return statement in it. And it's going to f3. So it's going to give us 6. But this is it's a bit more complicated than we were forced to. We would have had to. So we can do f4, and notice that for arrow functions, I can do something like with x, x times 2. Right, so for any x, what's evaluated is x times 2. And this is also going to work. Right, now I can see that if I talk about, I said that in order to put a function in a key in an object, the functions should be values. And this is a good start. It's a start which tells me I have an expression which evaluates the function, which I can put in a variable. Right, it's value like. But of course, it's not the whole story. Another thing I should be able to do is to be able to send a function as a parameter to another function. So let's abandon our discussion about functions for now. We'll come back to it. And let's get back to our arrays and see our higher order functions. Right? So it's functions which receive as parameters other functions. Now you might have met these in other languages. Because typically higher order functions, or in our case higher order methods, are generic enough concepts that you find them implemented everywhere. And the typical example is going to be map. Now what does map do? Now map typically, or if we take the Python implementation, so map in Python is a global function which receives as parameters a list of things and a transformation and returns another list of things, right? So for example, I have a list of integers, a transformation which is a function, and I get another list of something, of integers, let's say, but not necessarily, they can be another type. And what happens is, going through the source list element by element, I'm going to apply the transformation to each element to get an element in the destination list. So map typically maintains the cardinality of my list, right? So I get the same number of elements as I had initially. Now, if I think about map, so I said I have an implementation as a global function, and I could have definitely had that in JavaScript, but I can implement this in a different fashion because, like I said, the difference between a function and a method is that a method knows who this is, who the object it's called on is. So if I have a method, it's going to receive the object this as an implicit parameter, which means if I define map as a method on array, I only need one parameter, which is the transformation I want to perform. So let's have an array And let's assume we want exactly what we had earlier, which is the double of each of the values. So let's say we have a1 is a dot map, and here we need a transformation. So we're going to see with element times 2. And let's see it at the console. Right, so that worked. Now, what we've talked about is the simplest way of thinking about map. But JavaScript supports something which is a bit more complex. So first things first. Does map need to return a list of the same type? No. Whatever it's implemented. I can have strings based on numbers or numbers based on strings. The typical thing would be I have a list of strings representing numbers and I just map them to their parseInts. So that's one thing. The other thing is we've sent a transformation which has one parameter, the element. But actually, it can have up to 3 parameters. We've just ignored them because we're in JavaScript and we can. But the way that the transformation sent to map works is that it has 3 parameters, like I said. One which is the element, the other which is the index, and the other which is the array itself. Now I need the array itself for certain operations where I need the total length of the array. So let's try something else. So let's try a map which gives us a list of strings and uses the index. So I'm going to say a map. So element, index, and array. We're not going to use the array, but we're going to say that this actually evaluates to a string, and we're going to say it's going to be a of index equals element. Right, so that worked. So I got a list of strings mapped from the first list. Right, so this is somewhat how map works. What else do I have? Right, map isn't the only higher order function. So we're going to look over a set of them. Now, I now have apart from map, I have a set of higher order functions which receive as a parameter not a transformation but a predicate. Now, what a predicate is a function which evaluates to either true or false. So let's look at something which is called filter. Now, what filter does is given an array, it's going to give me another array which contains only the elements which respect some condition. Now let's say with e larger than 3. One sec. Right, so that's what filter does. But this is one of a set of methods. I have a couple more methods which receive a bunch more methods which receive a predicate. Now I have a pair of methods which are called sum and every. So given a predicate, sum is the equivalent of a large OR, applying that particular condition to every element. Because sum is going to tell me if any element respects that condition. And obviously, since it's the equivalent of a large OR, it's going to return some sort of Boolean value. And we're going to use the same condition. So it's a.sum this. Conversely, every is the equivalent of a large AND. So it tells me if all the elements respect some condition, a condition of some sort. And in our case, sum is going to give us true and every is going to give us false. Right, what else? Well, I saw that I have a traditional method on array which says index of. But what if I have to find the first element which respects some condition, but not necessarily equality? Or what if the array is an array of objects? So I don't necessarily know how to make them equal. Well, um, we're not going to treat the object one now, but for searching by a different condition for the first element which satisfies the condition, I have a pair of methods, one which is called find and the other which is called find index. So find is going to give me the element which matches the condition, or undefined if there's no such element. While find index is going to behave very much like index of, in the sense that it's going to give me the index of the element which respects some condition, or if that doesn't exist, -1. So let's see that. These are numbers, so let's say like this. So we're going to say a dot find, let's say a larger than 4, and 2 is find index. Right. Actually we didn't start from 0 this time. So the element which respects the condition larger than 4 is 5. And if I look at the index, it has index number 4. So it's 0, 1, 2, 3, 4, which actually shows up here. Right. Now, the last higher order method we want to look at, there's also one which is called for each, which allows me to just iterate through the array. But the last one, which is interesting to us, is that whenever we talk about the fundamental higher order methods, we have map and reduce. Right. So let's talk about reduce. There's actually two reduces possible and implemented in JavaScript. But let's talk about the principle of reduce. Now, in order to explain what happens with reduce, um, we should think about the sum of the elements of a vector. Right? Why? Well, if we think about, because we all know how to write it, and it's going to be easier to explain. So, if we think about how we calculate the sum of the elements of a vector in the simplest way, what we're going to do is we're going to have a variable in which to calculate the sum. Let's say to accumulate the sum, which is going to start from some initial value. In this case, it's going to be 0. In this case, it's going to be the neutral element for addition. And then we have to have some sort of expression which is going to update our variable, our accumulator. So we're going to iterate through the list, and for any element in the list, what we're going to do is we're going to add the value of the current element to whatever the previous value of the sum was, right? Which is why I say that the sum is being accumulated in a variable. It keeps growing, right? It's constructed iteratively. So now this is what reduce actually does. So let's say lat and 3 is a dot reduce. So we have to give it an initial value and some sort of expression which is going to tell me what the new value of the sum is after this step. So my parameters are going to be a bit different. So I'm going to have an accumulator, an element, and then an index and an array if need be. So accumulator element is going to be, so the new value of the accumulator is going to be accumulator plus element. And this is going to give us the sum. Now, this is actually something which is called a reduce left, because uh, we have to decide from which direction we're going to iterate through our array, the array we're reducing. Now, in the case of the sum of the elements of a vector, doesn't matter. Right? It doesn't matter if I calculate the sum starting from the end. It doesn't matter if I calculate the sum starting from the start. However, there are cases where it does matter. And for those cases, what I've actually written here is reduce left. Let's see one case where something like this matters. So let's say we have another array, A4, which looks like this. It's an array of arrays. Now, something to notice here is that reduce is called reduce because it reduces the dimensions of the input, right? So if I think about it, if I do the sum of an array, I have a list of things, of numbers, and I'm reducing it to one number. It's something with a lower dimension. So if I have a sum of an array of arrays, I'm going to reduce it to one array, right? If I have something three-dimensional, I'm going to reduce it to two dimensions, 5 to 4, and so forth. So let's say we have an array which looks like this. Right, so it's an array of arrays. And what we're going to do here is something for which we actually have a method on array. It's called flat. So we're going to flatten it. What we want to have is one array with all these elements. Now, how would that work? Well, first we need something to and this is it's a misnomer, to add the arrays, right? To concatenate the arrays. And we have a method called array.concat. Second of all, we have to think about what we're going to start from. So what's the neutral value for this array.concat? It's actually an empty array, right? It's the equivalent of 0 for some. So we're going to do something like this. We're going to say a5 is a4.reduce. And like I said, we're going to start from an empty array. And here, accumulator element, we're going to say accumulator.concat of element. And let's see what this is, what a5 is. Right, so it seems to have flattened my array. Now I have one array with all the elements. Awesome. However, what happens if we replace reduce with reduce right? And let's put it in a6. Now, if we did this for sum, for the sum, we would have gotten the same value. But in this case, it matters what direction I'm starting in. And I can see this is a bit different. If I look at it, I'm going to see I get a different result. And this is the reason why I have on one hand reduce and on the other hand reduce left. Right, so these are the most important higher order methods. Let's note something else. Let's see. Let's notice that many of them return an array, which means if they return an array, they can be chained to make our code even more succinct. Now, something to note here is that we want to use these higher order methods when it makes our code easier to read. If it doesn't, right, if I have some complex processing, I'm not supposed to nest them, for example, to say map of map of map of map, right? It's a map inside the transformation for a map. The objective here is to make our code easier to maintain. Um, so, but in this case, let's say we want to have the sum of the halves of all the elements which are divisible by 2 for A. How would we write that? And let's say let result is a dot something, and then we're going to just write result. Now we could write this in a half a page of code, but first of all we need all the elements which are divisible by 2. Now if they're divisible by 2, it means that the result of element modulo 2 is 0. So we could do this, so filter of some condition. We're going to say element modulo 2 equals triple equals 0. We could write this even simpler though, because we know that element modulo 2 does evaluate to something, right? It evaluates to a boolean. However, if we just leave it like this, it's actually going to give us all the odd elements instead of all the even elements. So we have to negate the result. Right, so let's see if that worked. Right, it worked. We only have the even elements. Now I said we want the half of it, right? But because filter returned an array, I can now map to element divided by 2. So that works. So we now have the halves. Now I said we want the sum, so we can reduce of accumulator element, and this is the thing we've seen earlier, a plus element starting from 0. So we've gotten our result, and it's really, well, once you get used to it, it's really easy to read, and it's really succinct, right? We've just written one line, and that's that. Right, so this about covers higher order methods for array. These are important because we're going to frequently be using map. Because if you think about making a web request and getting a list of objects from somewhere, you request a list of kittens, you get a list of kittens, and you have to draw something for each kitten, right? A table row or an element in a list, right? And map is ideal for this. Right, there's something which we've left out, which is
I have a question. Is this really used?
one sec. Let me just pause. So we want to talk about a couple more things. So we've looked over higher order methods over array. Like I said, there's a couple more, but they're not really that important. But we've left some things undiscussed, right? And the first one is the idea of variatic functions, and this I want to show you how this works. On one hand, on the other hand, I want to give you a little thinking subject, let's say, until next time. And I'll show you how it's done, but I'll show you next time. And the second thing is we've kept saying that functions are values, right? And this is, well, we've seen that we can send functions as parameters to other functions, but there's one trick left. There's something we've not seen, and maybe that's going to elucidate the subject, right? Maybe that's going to show us what the fact that functions are values means, which is what happens if we return a function from another function, if we have a generator function, a function which generates functions. Right, so first things first, let's take a little detour and look at variatic functions. And we're going to do a really simple example. We're going to do again the sum of the elements of the sum of a list of numbers. We're just going to represent it differently. So we're going to have a function which is called sum, and this is part of our, let's say, spec. We're just going to say that it has at least two things in it. So it's x and y, and then a bunch of other numbers. We don't know how many. So how would we say this? We don't know how many. Well, we're going to use the syntax for destructuring. Now, the syntax actually doesn't quite work completely in JavaScript. So the syntax I'm talking about is, for example, if I have an array, and the array is 1, 2, and I want to put this into a bunch of variables. So I want A to become 1 and B to become 2. I can write this in JavaScript, of course, like this. However, this isn't what I would have wanted. So what I could also do is destructure this explicitly. So I could maybe, in other languages, write something like this. Now this doesn't work, again, syntactically. But what this would do is it would take this array and transform it into the values. So again, destructuring is going to reduce the number of dimensions. Now, this syntax, though, is useful for something else, which is we're going to consider this function, and we're going to say it received an x, a y, and some sort of array called args, which is destructured over the rest of the parameters. And if I want to do the sum for this, I can do a reduce. So I'm going to say it's the sum of args starting from, so it's the sum of args starting from whatever x plus y is. Right, because I said that I know, I'm not validating anything, but I know that that I have at least x and y. And I can see that this works. And we can say sum of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, h is 9, 9, 9, 9. Right, and it's 55. Right, so the interesting part here is that I've considered, in order to work with it, I've considered that the rest of the parameters, the rest args, are actually an array which is destructured. Now, if I look at this, I might wonder something else. Can I write the prototype for any function? So a prototype which covers any function, at least all the functions defined with function. Well, I actually can. So I can do something like function, any function, which is going to be this. And this is the prototype for any function. Now, why would I want to have that? What would it be? Would it be useful for? Well, let's think about something. Let's say we have a way, a mechanism for which to modify an existing function to add some functionality. Now, the typical application of this would be timing. Let's say we have a magic thing, a magic tool, through which to get an existing function and add timing functionality to it, so we know how long it takes to execute. Now, how would we refer to any function? Now, we could refer to it in this particular fashion. Right? Any function fits this description. We'll get back to this, but for now, this is variatic functions, and I can do functions with an arbitrary number of parameters. And we've already seen one, and it's Splice. Although at the time that Splice was implemented, the syntax for this was different. Right, now let's get back to our functions and see what happens when I return a function from another function. Okay. Radio. So let's say we have a function g. Now the first question, and we call the function g is somewhere here, and it's just going to write something to the console, so it's a bit more simple. So the first question is, can this function declare local variables? Of course it can, right? I can do let n equals 5 console log n. Right, so let's see this in action. Awesome. Now, could one of these local variables be a function? Well, we've declared variables which are functions in other parts of our little examples, so probably yes. So let's say let f is a function, and this is going to say console log inside, and we're going to call f here. Right, it's going to say inside everything's fine. Well, we have a function. Could we return this? Let's try that one. And now g is a generator, so we're going to say it's a function generator. So it's going to say let f equals, so let f equals g. Okay. And now we've returned a function. F contains a function, just like we would have written an expression here which evaluates to a function. And we can now call f. And the same thing happens. Until now, nothing particularly strange. But let's evolve this example a bit. And let's have function g, which returns a function. We're not even going to name it. And let's say g has a parameter. It's called base. And this one is going to say console log base. Right, so we're going to say let f1 is g of 10. And we're going to call f1. Now this is a bit stranger because it's going to give me 10. And let's think about it for a minute. Now base, whether I receive it as a parameter or it's a local variable, should only survive typically for as long as g survives. right? So G needs some space somewhere to store the parameter it received. It gets it, that's fine. It finishes its execution, and I would expect that that space is no longer referred and thus will be garbage collected. However, this doesn't seem to be the case, right? So G is executed here, and when I call F1, it refers to base, and base seems to still exist. Right, so let's see something even stranger. Let's say this is a generator for a base adder. So we're going to say something like base, say this is a function of x, and we're going to have base plus equals x, and we're going to have f1, let's call it 10 based adder. So it just adds stuff starting with 10. And let's have a 100 based adder. And let's call them a bunch of times, right? So we're just going to call them with 1. Right. Okay, so what would I expect somewhere else, right? What would I expect here? I'd expect that G finishes 100, finishes its execution, and then whenever I call 10 based adder, there's no base. Or whenever I call 100 based adder, there's no base. However, this is not what happens. 12. No? 11? 11. Oh, we forgot to write this to the console. Let's just say console log base. 11. Right, and it tells us 11, 12, 13, 101, and 14. So let's see what this means. This means that on one hand, each of these functions has a state, and on the other hand, the state is different. So what happened? Like we said earlier, this is a garbage collected language, which means that if there's no reference to something, it's going to be garbage collected. So let's see what happened here. So G needed somewhere to store base whenever it was called. Now, what it did is allocate some sort of scope, of inner scope, and it stored base in that scope. Now that scope, like we said earlier, is something which is really object-like and which can be referred. Now it returned f, it returned the function, this one, and then it forgot about its scope. Right? It gave up its reference, so the garbage collector should be free to collect it. However, what happens in JavaScript is that this inner scope actually has a reference to the outer scope, which means because this function was returned and it survived, the scope of G survived as well, because when the garbage collector came, it found a reference to it. There was still a reference, and the reference is in 10 based adder, which means 10 based adder is now free to operate on that scope, even though it's invisible to us. Whenever G was called again for 100 based adder, it forgot, at some point it gave up the reference to the scope it created last time. So it has to create a new one. It creates a new one, it returns the function, and that function has its own version of that scope. So it also has its own state, which means each one of these is going to be a function with a state. Now this is called a closure because whenever I return a function from another function, it is closed over the scope of the parent function, which means it prevents it from being garbage collected. And this is something which gives me functions with state. If I think about it, what I have here is a mechanism which is similar to OOP, but from a functional programming perspective, right? Because what I said I did with objects, so if I think about the goal I'm going for with objects, what I'm trying to do is to group some characteristics with some behavior, right? And here, what I'm doing is the same, only I'm starting from the different direction. I have one instance of behavior, and I group some state with it. Right, so this is the idea of a closure, and this is the idea of functions as values. Because what's actually happening here is that if I think about 10-based adder, it's clear that it doesn't contain the equivalent of a pointer to a function. It contains the equivalent of a pointer to a function and its context, which is this closure structure. Right. So this would be the idea of functions as values. Now, something else. What would closures be good for? Let's see about that. So I need a function which is going to remember its previous state. Now, one possible applications and this application of this, and this I'm just going to copy paste here, so we just talk about it, is that I might want a function which does something which is called memoization. So when would I need a function to remember its previous state? Now let's consider a function which does something which is resource consuming, right? It consumes a lot of computational resources or network resources or whatever. I might want to do a trade-off here, which is only run the function for new values. Now, obviously, I'm losing something. There's no free lunch. What I'm losing is the memory I'm using to store the function's previous results. And obviously, this doesn't fit all kinds of functions. So what my function would do is whenever it's invoked with a bunch of parameters, it would check if it has been invoked with those parameters before. And if it has, it would get the result from some sort of state. Now let's see this implemented. One sec. And we have this function, which is called fibgen. Now this is not all that consuming, but it reflects what we want to show. So this is a Fibonacci function. Now, in order for a function to have associated state to be a closure, I have to return it from another function. So the only role that fibgen has is to constitute the closure. And I see I have some cache. Now, why is the Fibonacci function a good candidate for this? Because it's going to recalculate the same thing multiple times. So if for example, I want to do Fibonacci of 100, I have to do Fibonacci of 99 and Fibonacci of 98. But in order to do 99, I also have to do 98. So I'm going to calculate that twice. What I might instead do is whenever the function is called with an index, I'm going to check in a cache if I've already processed that index. So I'm only going to process something whenever the index I'm being requested is higher than my previous highest index. And we can see this because when we call it with 153, uh, it's going to tell me found index for a bunch of things. Right. You see, it doesn't recalculate things that often. It finds them in cache. It's only calculated fib of 3 once actually, and it keeps on finding it in cache. Now, an interesting question appears here, and this is the thing I want you to think about until next time. Now, if I can memorize Fibonacci like this, and I have this sort of syntax, where is it? This sort of syntax. I had the syntax for any function. Could I write something which is a generic memoization mechanism? So I want a function which is called memoize, which when given as a parameter another function, returns it in such a way that the parameter function remembers its previous parameters. Right? It remembers its previous invocations and uses a cache. Uh, Now, before we take another question, we're approaching the end. So before we take another question break, let's see one last thing. This last thing is going to tie into what we're going to do next time. So we've talked generically about objects, and we've said functions are values. Thus, objects can be considered key value pair, list of key value pairs. And we've said that objects work very much like hash maps or hash tables. So we're gonna say let O, this is an empty object, and let's say it has an A and a B, which is some string. Now, what would make a function be a method on this object? Well, if I'd put a function here and let's call it do stuff, going to be function, and it says doing stuff. And I can say o.do stuff. Right, so let's look at this, see if it works. It does. But does this tell me this function is a method? Not really, no. Why? Because I said that the method has to know who this is. Right? So the thing that defines a method in opposition to a function isn't some magical thing. It's the fact that it can identify an object to which it is bound. So let's say doing stuff. Oh, 1 sec, because it's let's say doing stuff with, well, if I wrote a here, it wouldn't know where to get it from. So I have to do it like this, right? It's a from the current object and b from the current object. Right, and with this, we're going to see that this function is actually a method, right? It actually knows who this is. It's bound to that particular object. Right, so we're going to stop here. I'm going to stop the recording.